Yeah, good afternoon, guys. We're going to look at differentiation from first principle today. Differentiation from first principle. Differentiation from first principle. All right. So let's have a particular function y depends on hex. All right. So a function y depends on hex. So now we're going to rewrite this as this y plus change in this y will be equals to x plus change in hex. So this is going to be our equation 1, this is going to be our equation 2. So we're going to subtract equation 1 from equation 2. So we're going to have y plus theta y minus y, the right side minus the right side, then the left side minus the left side, so equals to x plus theta x minus x. All right, it's simply the left side minus the left side of equation 2 minus the left side of equation 1. So we have it here. So here y is going to take away y, then we have theta y left here equals to the same thing will happen here. X is going to take away x, so we're going to have theta x here. So now in order to get our change in y over change in x, we're going to divide both sides with theta x. So as you can see, theta x will cancel out theta x, will remain 1 here. So change in y over change in x equals to 1 from the first principle. All right. So, okay, let's look at another example. All right. So now let's say we have another function, number 2. We have another function y depends on x squared. The same thing we did in the first question. So we'll go to the same approach. So simple. So this is going to be, so don't forget this is 1. This is equation 1. The same thing is going to happen. So this is y plus change, a particular change in y, equals to, now this x, this is x squared. So you are going to open a bracket for him. So x is going to be x plus a certain change in hex, all squared. All right, because everything here inside this bracket is the hex. So x plus change in hex, so everything is squared. All right, so the same thing we did equation 2, or let's try and open the brackets here before we do that, before we go into that. So the y plus theta y equals 2. So when we expand this, we're going to have x all squared plus 2x theta x plus theta x all squared. All right, so we're going to have that. So the same thing, you subtract equation 1 from equation 2. We subtract equation 1 from equation 2. So simply the left hand side of equation 2 minus the left hand side equation 1. All right, y plus theta y minus y equals to the same thing for the right hand side, x all squared plus 2x theta x plus theta x all squared minus x all squared. So from here, y will cancel y, so we have theta y equals to, now x squared and x squared, they'll cancel out each other. So we're going to have 2x theta x plus theta x all squared. All right, again, the same approach to find the Differentiation. Differentiation is the y over change in y over change in x. All right. So we're going to divide both sides by delta x, delta x, delta x. All right. So here we're going to have delta y over delta x equals to this delta x will cancel delta x, so we have 2x here plus, now delta x will cancel, it will remain one delta x here, delta x. So but we still have delta x here, so what do we do? So we have 2x plus delta x, so but delta x is still left there in the right hand side. So what do we do? So we apply limit to it. All right, so delta y over delta x, as limit of delta x goes to 0 equals to 2x plus, now 0, because we have set delta x to go to 0, so this here is going to be 0. All right, because of this limit you have set this delta x to be 0. So at the end of the day we have delta x, the y over delta x, as the limit of delta x goes to 0 is 2x. All right, so simple. I want us to solve another example. All right, another example here we have 3, y equals to 2x squared plus 5. All right, the same thing, just apply the same principle. All right, now this y is going to be what? Y plus a certain change in y equals to, don't forget this x, you understand, is going to change to x plus a certain change in x, then square, because everything here is x, you understand, then plus 5. Equation 1, equation 2. So we have equation 2 minus equation 1. All right. So we have y plus delta y minus y equals to 2 into x plus delta x all squared plus 5 minus, let's open brackets, 2x squared plus 5. All right, left side of equation 1. All right, so let's continue. This will cancel out this, so we have delta y equals to, so let's expand this. So this is 2 into, this is x squared plus 2x delta x plus delta x all squared plus 5 minus 2x squared minus times plus, that's minus 5. So delta y equals to, so let's open the brackets here. All right, so we have 2x squared plus 4x delta x plus 2 times x squared, 2x squared, 2 times 2x delta x, 4x delta x, then 2 times this is 2 delta x all squared. All right, then plus 5. No, this 5 and this 5 will cancel out each other, so let us waste time. So this will be there. What's left there is minus 2x squared. All right, so let's continue. So delta y equals to, yes, this will also knock out this 2x squared minus 2x squared minus x squared, knock out. So we are left with 4x delta x plus 2 into delta x all squared. All right, so here, getting here, what do we do now? First, we divide through by delta x. All right, okay, so delta y over delta x equals to, this delta x will cancel delta x, so we are left with 4x here plus 2 into, it will 1 will be left here, delta x. So again, we still have delta x left here, so we have to set it to 0, the limit to 0. So we have delta y over delta x, as delta x approaches 0 is 4x plus 0. So because this thing has been set to 0, so once it's set to 0, it is 0. So 2 times 0 is 0. So we have this. So the final answer is 4x. The final answer is 4x, as change in x, delta x approaches 0. Thank you so much. Please watch this video very closely, and I'm waiting for your response. Thank you.